Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Live today in Tehachapi at Airstreams Renewables Incorporated, and I am with Rick Gould. How are you doing today?
I'm doing well.
Can you let everybody know out there what your position is here at Airstreams?
My position is Training and Education Development Specialist, which is fancy for I'm in charge of working on updating the curriculum that we teach here and standardizing what the instructors are teaching.
What exactly happens here at Airstreams?
At Airstreams, we have a 6-week course on teaching the basics of the skills necessary for being a wind turbine technician or telecommunications tower technician. The skills we provide can go beyond just those jobs, but that's usually generally our primary focus. And it's a wide range of skills that are required for the job.
Now, how old do you have to be to come?
I've had, in one class, I had an 18-year-old who just graduated Tehachapi High School and a 60-year-old.
Wow.
And they both had jobs on graduation day.
Now, we have some hands-on going on in front of us. Can we go on in there and kind of explain to us exactly what these gentlemen are doing?
Absolutely.
Okay.
So for us here, getting to the job is just part of the task. Once we get up tower, that's when the work begins. But sometimes just getting up tower, especially when you have a 300-foot ladder to climb, requires obviously physical effort. And because we're 300 feet in the air, or maybe at least several hundred feet in the air, we don't exactly have anybody that can come help us when things go wrong. So what we're teaching here is the basics and fundamentals of how to climb and how to conduct rescues in the event something goes wrong.
And you have things going on all over. You have something going on over there on that wall, and then way up top here, and then on both sides.
We've got several different things going on. We've got some practice climbing going on here to get them used to just climbing up and down a ladder, because climbing up and down a vertical ladder is not the kind of thing that most of us do on a regular basis. We have some rescues going on here up top. We've got victims that are hanging over the side. We've got an individual here that's practicing doing an evacuation using an evacuation descent device.
He was coming down.
He was coming down.
Okay, can we kind of go over the rigging that they're attached to?
Sure. We have a number of backup safety devices here. So we have some ropes that provide a backup fall protection, and then some devices up there like you see connected to that individual and that individual, which you call self-retracting lanyard. And that's just a backup for them because it's a training environment. The gear that they're using is what we're trying to focus on them getting used to using. They have a lot of equipment, a harness, fall arrest lanyards, a device that grabs a hold of a cable like you see right here in the corner, and they have to learn how to use all that stuff.
How much weight will they have carrying on them?
For a basic harness and fall protection equipment, it's probably about at least 30 to 40 pounds of gear.
That's a lot. So over there they're doing a rescue.
They're doing a rescue over there.
Okay, so obviously, because we have white hats and we have orange hats. The orange hats are?
The orange hats are the instructors.
Helping
and
out.
So that allows us to easily look around and identify where's one of the instructors and one of the staff.
What is that he's turning? Sorry, what is that he's turning
that
right
is
now?
Called
I can kind of see.
Yeah, it's called a track tail device. And in there is a gear mechanism that grabs a hold of the rope. And there's a wheel that they turn. So it's a mechanical advantage that allows them to just turn that wheel, and they can raise a victim. And in raising that victim, they're able to get that victim up off of whatever might have caught their fall, get them off of that, and then we can lower them down tower.
Okay. So So other things that help besides that, with that rig, what other things do they use to help them bring the victim up?
Well, we have some work positioning lanyards, which is a device that connects from one side of the hip to the other. His is at the bottom of his harness there. It's kind of coiled up. You can see them hanging off their harnesses right there.
Like the blue right there?
No, the blue is a fall arrest lanyard, but
Okay.
the what's on his right hip, it looks like a rope kind of coiled up.
Yes, I see it.
That's what we call a work positioning lanyard. Them to connect to the tower so that they can not have to hang on to the tower and they can use their hands. But we can use that device in a multitude of ways. We can use it to redirect a descent line in the event that we need to lower a victim, but maybe right below them. So in order to get around the obstruction, we might take that work positioning lanyard and pull that descent line out away from the obstruction. We can also use it to package up a victim. Because if the person's unconscious, their legs or their arms might kind of tend to flail about and cause further injury. So we can use that work position to essentially kind of maybe wrap up their feet and get the victim in a nice, comfortable position.
Is there ever a time that they are up there by themselves that they're going to have to rescue themselves?
We don't work alone. We always work in a minimum of 2 people up the tower, always. But because we don't have professional rescuers that can come up there and do the rescue, if there's a team of 2 and one of that team members is incapacitated or ill or something like that, then yes, the rescue might be conducted by one person. Or at least started with one person.
When they get up there, is there something that they have to hook to that's automatically there, or do they have to carry it up there with them to connect it?
Good question.
For safety.
Generally speaking, most towers are going to have some sort of device, I should say structure to attach to. We do have what we call engineered anchors. They're usually painted yellow. And it's a mechanical plate with maybe a loop that we can tie into. And they're usually all over inside the wind towers, at least on the newer ones. Some of the older ones that were built before the fall protection standard got to be the way it is might not have them.
Okay.
But there's always something to connect
Something to connect to. Okay, so when we come back, there's a lot of mathematics that goes with it.
There can be, yes.
And being an instructor, you're going to instruct us on some mathematics that
ma'am.
will help out. We are back live in Tehachapi at Airstreams Renewables Incorporated with Rick Gould. And we are outside watching the students practice rescues.
Yes, ma'am.
Okay, the course is 6 weeks, correct?
Yes, ma'am.
And exactly why are the students coming for that? What is their goal?
Their goal essentially is to get jobs in wind energy and telecommunications. Again, that's our focus. Our skill set can get them jobs outside of those 2 industries, but that's typically where our focal point is.
So that aspect that we just saw, that's just one part of the job.
That's just one aspect of it. That's
Okay.
just one week of the training.
And so they obviously have a classroom
Yes, ma'am.
where they need to learn some mathematics.
Yeah, oh boy.
Okay, take it away. Show us what they need to be learning.
So there's a wide number of skills that we teach here, and on several of the different areas of our training, one of the first ones is rigging. And we have to teach them how to pick up a large piece of equipment, maybe a 30,000 pound gearbox or a blade that weighs 25,000 pounds. And we have to be able to do this safely. In order to be able to do it safely, we have certain rigging hardware like slings that would be used to pick up these devices. These are just smaller versions of what might be used actually out there in the field. We also have shackles. There's a pretty good shackle. Drop that one might hurt. And we have some smaller ones. And these are just examples of what we might find out there in the field. But the trick is we have to make sure that if we're picking up this 30,000 pound gearbox, that we don't exceed what that equipment is capable of lifting. So we have some math that has to be done in order to figure that out. And one of the things that goes along with doing the math is our rigging handbook here. And we have all kinds of tables. You can see there's some formula. I opened right up to some formulas. So we have all kinds of math related. I'm not even trying to, and I'll open right up to
Pythagorean
Pythagorean's theorem
All
right there.
That's what I'm looking at.
So we don't get terribly heavy into the math because this is an introduction to rigging. There are multiple levels that can get very, very complicated. But this is a fairly basic math problem here that we might do. So we have this load, whatever it is. I've just got let's say a chunk of steel there. I've got a shackle up top, and I've got a couple slings suspended from it, and then going down to the what we'll call a pick point. Well, one might look at that 30,000-pound weight and think that each one of these slings is carrying 15,000 pounds. Divide the 30,000 by 2. Well, this isn't true. There's actually a lot more stress in each one of these slings than the 15,000 that it appears to be. So we have some math here that we need to figure out. So we might ask ourselves, well, what does that sling need to be capable of? It's more than 15,000, but what is it? So we have a formula that is sling stress is going to equal the weight of the load divided by the number of the legs times something that we call load angle factor.
Now the legs you're talking about.
The legs would be these two legs right
Okay.
there. So we need to know these three pieces of the information in order to calculate the sling stress and then figure out what size sling that we're going to use. So we know the weight, which is 30,000 pounds. We know the number of legs, which is 2. What we don't know is this thing called load angle factor. In order to calculate load angle factor, there's 2 ways we can do that. It has to do with this angle right here. We can figure out that angle with a little tool like this that we literally just lay right against the sling, and we read the angle that's on the indicator. And that gives us our angle. We then go from knowing that angle to a chart in our book that might tell us a load angle factor of whatever it might be, 1.55 or 1.414.
So if it was 40 degrees,
It
then
would be
that
1.55.
And they would take this, they would be on the job.
Would be
with
on the
that.
job. Yep, it'll
Okay.
be part of the toolbox. And this is kind of thing, you know, my old one is pretty worn because I carried it with me each and every day. Now, I said there's 2 ways we can figure out load angle factor. We can either use this angle finder, or we can measure the height and then the sling length. And we can divide the sling length by the height. So I'm going to do that.
Now, when this right here, when you're on the job, are you going exactly to the center of?
Yes, ma'am.
Okay.
I'm going to draw a triangle, and I try to do that the best I can. I think my fingers kind of wiped it out, but basically we're trying to, if you picture a triangle that goes from this point to this point to this point, that's our triangle.
So we have our 2 ways, either the tool, or if you don't, you have the measurement and should come out.
And so I came up with 13, and I think it was 10 inches. So I'll do a little bit of just
So-
easy rounding.
Okay, so which we would have, if we would divide it, say it would come out to our 1.55, or it would match with what we have our book.
It should come out to 1.3 in this case.
So not only you have simple calculations, foundational skills, we do have a little bit of geometry with the measurement of the
Yes, ma'am.
angles. And this is just like one little aspect of
Just
math
one,
AIT.
this is fairly basic rigging level material.
Real quick, before we go back to the studios, what is the basic thing that they need to know in mathematics?
As far as coming to the school, fortunately for our curriculum is designed so that you don't have to know really any engineering, science, or math other than the basic science that you would learn probably up through junior high. The math isn't really all that complicated, so you know we don't want people to go, oh no, there's too much math there at Airstreams, run away. No,
So just foundational skills.
foundational skills.
All right, and we're going to talk a little bit more when we come back, but we're going to head back to the studio. We are back live with Rick Gould from Airstreams Renewables Incorporated in Tehachapi. And I want to go where we left off. We were talking about this, the tension on the lines, correct? So let's kind of finish off this problem because we kind of stopped here.
We stopped here with the measurements. I took more accurate measurements using the sling length and the height, and I came up with 13 inches and 10 inches. So I divide the 13 inches by 10 inches, and I come up with 1.3. And that 1.3 is my load angle factor, which I then put in this formula. I'll multiply 30,000, take 30,000 pounds, divide it by 2, and then multiply it times that 1.3.
And again, you have to use your order of operations. So we
ma'am.
need to divide before we multiply.
And I came up with 19,500 pounds.
Okay, what does that mean, the 19,500?
That is the amount of tension that each one of these slings feel. It's more than half of that weight, because what happens when we bring them from vertical to a less vertical, more horizontal position, there's more stress there.
Okay.
And we have to account for that stress.
And we were talking about this, which is called again, the
shackle up top?
shackle up top. Okay, so you have this much weight. So we were talking about how the shackle, what do we need to do with the shackle then?
We need to figure out how much weight that shackle can hold. And so the load here is actually 30,000 pounds suspended by that shackle. As long as those slings are within a certain range of angular movement, then we can use the shackle at its fully rated capacity.
So this shackle we were looking at earlier,
Yes,
which
ma'am.
is kind of heavy. How much is 9 tons, you said?
I think it was 9.5 tons, if I remember correctly.
Okay, so would this shackle work, or is it too small?
That one is actually too small.
So you'd have to get a bigger one.
Yep, or use more than one and do a whole different way of lifting.
Okay, because it has to hold
Yes, ma'am.
that.
Well, no, it has to hold 30,000
The
pounds.
30,000 pounds, exactly. Okay, real quick, you have one more problem for
Okay,
us.
so a real quick electrical problem here. I worked out some of the math already. I've got a battery here with 3 resistors in what we call series. I've got a 1 ohm resistor, a 2 ohm resistor, and a 5 ohm resistor, all being powered by a 24 volt DC battery. The total resistance is simply 1 plus 2 plus 5, which my math comes up with 8 ohms. And I can figure out how much current is flowing through this circuit by taking something we call Ohm's law. And I'm going to take the current version, and I'm going to take current, which the letter I represents, and I'm going to divide voltage, E, by resistance. So I have 24 volts divided by 8 ohms, and I was smart enough to pick out numbers that I can do in my head, and I come up with 3 amps.
So just another simple.
Another simple math problem.
Okay. Now, there was one thing, because we were out there and there's a lot of gentlemen out there.
Yes, ma'am.
What about the women?
They do absolutely fine. I have had a prior Marine that went through here that absolutely knocked my socks off. She was amazing from day one to the end and the last day. And so it really doesn't matter what your background is, what your education level is, what gender is, what your color is. Here at Airstreams, we're obviously equal opportunity, and the industry is very widely equal opportunity as well.
What is their goal? Once they're done with 6 weeks, what is their goal from there?
Their goal is to obviously get a job. We operate in a very short time frame because our business model aims at somebody who needs to get a job very soon. So they don't have 2 years to go through a college program. We give them a crash course in introduction and a bunch of different skills so that they can go out there and get jobs. We also provide job placement assistance, and we train them on how to interview and do resumes.
Well, first of all, thank you so much for letting us come out today.
Absolutely.
This is a little gift
Well,
from us to
well,
say
thank you.
thank you. And I have to say, the knowledge you have is amazing. The time has been wonderful. And again, thank you for allowing us to come out here
it was my
and
pleasure.
check it all out.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.